The Karata RN09 road project in Algeria is a major infrastructure project designed to improve connectivity in rugged mountainous regions. Özgun İnşaat, a leading construction company, is responsible for the construction of viaducts and tunnels in this project. The Karata RN09 road project is located in a rugged mountainous terrain with deep valleys and steep slopes. To connect geographically separated regions, the route requires the construction of multiple viaducts of great height and length. The main objectives of the project are to ensure smooth traffic flow, reduce travel time, and promote regional economic development. The viaducts are designed with pre-stressed concrete box girder structures, providing superior load-bearing capacity and long-term durability. The construction of the viaduct on the RN09 route is carried out through the following main steps. First, the terrain is surveyed in detail using LiDAR and drone technology to collect accurate data. On this basis, the viaduct is designed with pre-stressed concrete piers and box girders. This structure optimizes load-bearing capacity, saves costs, and is suitable for complex terrain. The construction area is cleaned with excavators and bulldozers. Then, deep concrete piles are drilled and reinforced to ensure the load-bearing capacity of the piers on weak ground. The reinforced concrete foundations are cast in place with a modern formwork system, ensuring accuracy and stability. The piers are built using an automatic climbing formwork system, helping to construct high piers quickly and safely. This system allows piers to be constructed in segments without the need for large scaffolding, suitable for construction conditions on steep terrain. The pre-stressed concrete beams were manufactured at a foundry near the construction site, then transported and installed on-site. The incremental launching method was used, in which the beams were assembled at one end of the bridge and gradually pushed to the other side using a hydraulic jack system. This technique reduces the need for large cranes and ensures high precision. After installation, the bridge deck is covered with a waterproof layer and asphalt to protect the structure. A railing system, signs, and lighting were also installed to ensure traffic safety. The construction of the RN09 viaduct applied many advanced technical solutions. One of them is the use of pre-stressed concrete, with steel cables stretched inside the beams to increase load-bearing capacity and reduce deformation. Automatic climbing formwork technology allows the construction of high bridge piers accurately, even in difficult-to-access terrain. In addition, the push-pull method is an effective solution for installing long bridge girders without the need for scaffolding or large lifting equipment, minimizing construction risks. The Karata RN09 road project brings many great benefits. First, the viaducts help overcome high mountain terrain and deep valleys, shortening travel time and enhancing connectivity between regions. The bridge structure is designed to withstand heavy loads and harsh weather conditions, ensuring safety and long-term durability. Economically, the RN09 route not only improves traffic, but also promotes the circulation of goods and economic development for the Karata region and neighboring areas. The Karata RN09 road project is a typical example of applying advanced construction technologies to complex infrastructure projects. With creativity and high technical skills, Özgun İnşaat Company completed the project efficiently, ensuring quality and progress. This is a typical project, making an important contribution to the sustainable development of Algeria. In 2017, the Bella Vista Canal in Chile, an important irrigation route in the region, was installed with a concrete canvas CC canal lining by Agrotech. This is an innovative solution to protect the canal from erosion, reduce water leakage, and increase durability. Concrete canvas CC is an innovative concrete fabric designed to combine the flexibility of a fabric with the durability of concrete. The material consists of 3 layers: a reinforcement fabric layer to increase tensile strength, a dry cement powder layer that works when wet, forming a solid concrete layer, and a waterproof membrane layer to prevent water infiltration, ensuring a durable concrete layer. When watered, the cement layer inside will react chemically, harden within 24 hours, forming a durable concrete layer that is resistant to erosion, chemicals, and harsh weather conditions. The Bella Vista Canal is heavily impacted by water flow, leading to erosion and water leakage, wasting resources. The complex terrain and the need for quick completion also posed a big challenge. Let's see how Agrotech installed it. The canal bed and banks were cleaned with excavators and scrapers to remove mud, sand, and soil. Next, a bulldozer was used to shape the canal bed according to the design, creating a flat and stable foundation. The concrete canvas rolls were transported to the construction site and laid along the canal bed and banks. A small crane or a truck-mounted crane was used to deploy the rolls precisely. The CC layer was then fixed with pins or anchors at the edges to keep it firmly in place. The CC layer was wetted with a water spray system or a tanker truck to activate the cementation reaction. This process ensured that the CC layer hardened into concrete within 24 hours. After the CC layer had hardened, the entire surface was inspected to ensure there were no gaps or water leaks. The joints between the CC panels were thoroughly inspected to ensure tightness and durability. The Bella Vista project in 2017 is a testament to the flexibility and effectiveness of concrete canvas in the irrigation sector. It is also a model for implementing similar projects in areas with harsh terrain and weather conditions. The Alse Canal is an important irrigation project that not only helps control water flow and reduce the risk of flooding, but also supports transportation and economic development in the region. One of the key factors to ensure the durability and long-term efficiency of the canal is the asphalt paving on the contact surfaces. The asphalt paving technology applied here uses high-quality materials and modern equipment, meeting strict requirements for durability, waterproofing, and load-bearing capacity. This canal is an important traffic route, serving the transportation of goods, controlling water flow, and enhancing flood resistance. The system has a large length. The canal bed is designed to ensure durability against the impact of water flow, weather, and traffic on the canal. Before paving, the canal surface must be carefully prepared. First, road sweepers and pressure washers are used to clean dirt and mud. If cracks or holes appear on the surface, they are treated with reinforcing materials, such as concrete or cement. Then, a layer of adhesive, bitumen emulsion, is sprayed evenly onto the base to increase the adhesion between the asphalt and the canal surface. The asphalt paving process is carried out using a specialized asphalt paver. The asphalt used is a mixture of bitumen and aggregate, stone, gravel, sand, heated at a temperature of 120 to 160 degrees Celsius to ensure flexibility and ease of construction. The asphalt paver with an automatic conveyor system will spread the asphalt evenly on the canal surface. At the same time, laser and GPS sensors on the machine help adjust the thickness and slope of the asphalt layer, ensuring absolute accuracy. After the asphalt is paved, the road roller will perform the task of compacting the asphalt layer, Steel wheel rollers are used to create a smooth flatness, while tire rollers will handle hard-to-reach areas to ensure uniformity. This compaction process helps to eliminate voids, increase the durability and resistance of the asphalt layer. There are 3 main types of machines used in the process, including 1. Asphalt spreader. This is the key equipment with the ability to automatically adjust the thickness and slope of the asphalt layer, ensuring uniformity and accuracy. 2. Roller. Using a combination of steel wheel and tire rollers to achieve the highest compaction efficiency. 3. Bitumen sprayer. Supports spraying adhesive before spreading asphalt, creating a tight bond between the base and the asphalt layer. The asphalt spreading process not only provides a durable, waterproof, and load-bearing surface, but also helps to prolong the life of the canal, minimizing maintenance costs. Thanks to that, the ALS Canal not only meets technical requirements, but also becomes a model in the construction of similar projects. ACO Group is one of the world's leading providers of innovative drainage solutions. Among their standout products are the ACO Self-Hexylene and ACO Hexylene 2.0 plastic gutter systems. These are ideal for residential drainage applications such as gardens, driveways, walkways, and areas requiring light drainage. With smart design, sustainable materials, and easy installation, these products meet drainage needs in a variety of environments. The ACO Hexylene plastic gutter system is made from high-quality polypropylene, ensuring superior durability in harsh weather conditions and good load-bearing capacity. In addition, the gutters are designed with a honeycomb structure to increase rigidity while remaining light in weight, making them easy to transport and install. The ACO Hexylene gutter system has many outstanding advantages, including a flexible design that allows easy cutting to suit the required length. The product also comes with a variety of screens, from galvanized steel to composite plastic, to meet the aesthetic and load-bearing needs of each specific area. The surface of the gutter is designed to be dirt-resistant, making cleaning and maintenance easier. In addition, this system is also suitable for many civil applications, such as garden drainage, driveways, walkways, or light parking lots. This brings high flexibility and efficiency, especially in areas requiring sustainable and easy-to-maintain drainage systems. The installation process of the ACO Hexylene plastic gutter system includes many important steps to ensure drainage efficiency and long-term durability. The first step is to prepare the site, in which it is necessary to locate the drainage route and dig a trench with a width larger than the gutter by about 100 to 150 millimeters on each side. The trench must be deep enough to create a concrete base of at least 50 to 100 millimeters thick under the gutter. A concrete base is then poured into the bottom of the trench to create a stable surface. A minimum slope of 1% along the length of the system must be ensured for effective drainage. The plastic gutter sections are connected by fitting and locking with locking grooves at both ends. Once the gutters are in place, concrete is poured around the gutter, creating a protective layer against shifting or deformation under load. After the concrete layer has dried, the screen is attached to the gutter with the supplied pins or screws, and the drainage system is tested by pouring water. The ACO Hexylene system uses many advanced techniques to ensure efficiency. A minimum slope of 1% is carefully designed to optimize drainage capacity. In addition, M20 grade concrete is used to create a solid base and protection. Throughout the process, careful compaction and positioning steps are carried out to avoid voids in the concrete. An important note is to regularly check and clean the system to ensure there is no blockage due to dirt or leaves. The screen is designed to be easy to disassemble, helping to simplify maintenance. Using ACO self-hexylene and ACO hexylene 2.0 brings many outstanding benefits. First, the product is highly durable thanks to its anti-corrosion and strong polypropylene plastic material. Second, the smart design helps shorten construction time and reduce installation costs. In addition, the aesthetics of the product with diverse screens and sophisticated gutter surfaces also help to enhance the value of civil works. This product also brings long-term economic efficiency thanks to its good resistance to harsh conditions, minimizing maintenance and replacement costs. Thanks to that, ACO hexylene has become a popular solution globally, trusted in many civil drainage projects. The ACO self-hexylene and ACO hexylene 2.0 plastic gutter systems not only meet the need for efficient drainage, but also provide a user-friendly solution for the installer and user. This simple installation process, combined with smart design and high durability, has made this product the first choice for civil drainage projects. With a combination of flexibility, efficiency, and aesthetics, this is a reliable product for all modern drainage needs.